this video, we're going to talk about the domain for composition of functions. So we don't just look at the result when we are looking at the domain of a composition. We actually have to consider the inner function, the one we plug in to the function. So let's look at an example. In this case, we're being asked to find the domain for f of g of x. So in this case, g of x is the inner function. So I'm concerned about its domain to start with. So I'm not allowed to have negatives under the radical. I can have 0, but not negatives. So I need x minus 2 to be bigger than or equal to 0, which means x needs to be bigger than or equal to 2 if I just solve for x, right? Add the 2 to both sides. Okay, so I already know, based on the fact that g of x has this restriction, in the domain for my result, this has to be part of it. X needs to be bigger than or equal to 2, period. All right. Okay, so now let's find f of g of x. So let's plug that in. So I'm going to plug square root of x minus 2 into f of x, which is going to be the square root of x minus 2 squared, which cancels out the radical. So that just becomes x minus 2. And I'm going to drop the parentheses, minus 1. Okay, so here we go, x minus 3. So based on just this, x can't equal 3. Based on just this result. But I have to also include that x needs to be bigger than or equal to 2. So combining those two together, that would mean that we'd go from 2 to 3, but then I'd have to exclude 3, and then I'm good from 3 to infinity. So that would be the domain for this equation. So if I hadn't come out with a fraction, I just would have said from 2 to infinity, because I'd be basing it on the domain for g of x. But because I came out with a fraction, it also had a restriction, not allowed to equal 3. So I had to exclude 3 in my interval notation. That's why I have that union symbol, and I'm breaking it up at 3. All right, let's try another one. This time we are given f is 1 over x minus 2, g is 1 over x. So again, inner function is still g of x. Here, I'll do it in green. So for this one, x can't be 0, period. Just can't be 0. So we start with that. So now let's find f of g of x. So I'm going to plug in 1 over x into this equation. All right, now we haven't really worked with any of these in the videos, so we need to clear the double fraction, the fact that this is a complex fraction. So I'm going to multiply everything by x, numerator and denominator. And what that does is that leaves me with an x in the numerator, and it cancels this x in the denominator, so I'm left with a 1 minus 2x. All right, there we go. That's the result. Now I have another restriction. I can't let this equal 0, that denominator, which if I solve this, let's see, negative 2x can't equal negative 1. If I subtract the negative 1, divide by negative 2, so x can't equal 1/2. Okay, so there's my two restrictions. It can't be equal to 1/2 or 0. It can be anything else. So it can go from negative infinity up to 0, then from 0 to 1/2, and then 1/2 to infinity. It can be anything but 0 and 1/2. So that's how we exclude those two functions. Those two numbers. Okay, so now let's look at working backwards. In other words, if we were to assume that something is the result of a composition of functions, what would the original two functions be? So let's look at this example. If I were to try to say what this is, what the two original functions are, there's a few ways to do this. Typically, I look to simplify something that complicates this. In other words, the fact that I have a lot of stuff under the square root kind of makes me feel like A. So let's say, here, we'll call it G and H, all right? So let's say that G of x equals 5 minus x squared. That would mean that h of x, the function I was plugging that into, would look like 3 plus the square root of just x, because I'd be plugging this thing a radical. So this f of x is the result of composing h with g. In other words, plugging g into h. We could write it with the other notation, which we haven't seen in a while, h composed of g of x. And that would be g of x, and that would be h of x. And that's it.